morning, Ivan. Can you hear me okay?
Yeah, we can hear you.
Great.
All right.
Give it one more minute before I get started. All right, well, let's get rolling. Good morning, everybody. I hope you're having a nice week. Couple quick announcements. So you may have noticed on Moodle, next week we have our Chapter 4 quiz. Originally, it was scheduled on Monday, and when I scheduled it, I didn't realize that that was sort of the weekend holiday and that we have Monday off from school. So I've moved it to Tuesday. So our Chapter 4 quiz is on Tuesday, April 19th. I actually moved it a couple weeks ago, so you may not have even noticed it was on the holiday before, but it is scheduled for the 19th. So we are finishing up our Chapter 4 work this week. And within that, we are doing applications. And so with the applications, there's sort of 3 different application areas that we're going to cover. So the first one is economics. Then we're also cover biology and chemistry. So today we're going to be doing the business section of applications. And this particular lecture is potentially short. And the reason for that is because when we go to do the work of this section, we actually have to pull in everything we've already done with economics. So, the stuff from section 1.4, where we learned about the original cost and revenue, and then 2.5, where we talked about marginal cost and revenue. And now we're going to be pulling in everything we've learned from earlier in Chapter 4 to talk about how we might apply that to cost and revenue. So when you're preparing to do the mini quiz and looking at the homework, you're going to have to go back and look at those other sections from business that we've already covered if you don't remember some of the things we've talked about. So like I said, this lecture is a little bit shorter because you do have to go back and review as sort of part of preparation for this section. So we're going to go over that today. We're going to look at sort of the main examples and how we might look at those. And then again, when you're doing the homework, you may have to reference back to some of the other sections that we've covered, which again was, I believe 1.4 was the original, and then 2.5 was the second time, and then this particular lecture. So we're going to kind of culminate it all by bringing all 3 sections together. So I think that's it for announcements. I'm going to go ahead and switch over to the dot cam. Okay. So again, we're bringing in our profit, revenue, and cost, which we've talked about in a couple different contexts over this course. I think this might actually be the last time that we talk about profit, revenue, and cost. Cost comes up a little tiny bit in Chapter 5, but the other 2 do not. So this is our last sort of specifically business related section. This will come back in Math 128 a little bit if you go on to take that. So keep that in mind and keep good notes if you're planning on taking Math 128 either in the summer with me or in the fall with somebody else. This will sort of circle back. Okay, so as a sort of review of what we know, we have cost, which we write C of Q, which is the amount of money it takes from the seller's perspective to make a product. So you are the producer. How much does it cost you to make your product, right? The upfront cost, the variable cost, we talked about all of that. And we talked about the fixed cost, C of 0, and that's the cost before you've actually made anything. So that might include like equipment you bought, or maybe you bought a factory, right? Before you've actually made anything, sometimes you spend money. Those are called your fixed costs. Revenue, which is R of Q, is the amount of money taken in from selling a product. So Typically, our default is that revenue is price times quantity unless we are told otherwise. So P is the price that you're charging for your item, and Q is the number that you sell. P is a constant and Q is the variable. And then our profit was the amount of money that you make by producing and selling an item, right? So you take your revenue and you subtract off your cost. So we talked about marginal cost. Marginal cost is the derivative of cost. It tells us how much it costs to make one additional product, right? Marginal revenue, again, is going to be the derivative of the revenue function, and it's going to tell you the additional revenue to sell one more. And the marginal profit is the derivative of the profit function, which will tell you the additional profit from making and selling one additional item. So these are all the definitions we had from 1.4. Here's what we learned in 2.5. Now we want to start putting it together with what we've learned in chapter 4. So we're going to work on this example 1 here that has a lot of parts, and it sort of brings in some of the old stuff, some of the new stuff. But here's the situation. Suppose the cost to produce an item is given by C of Q equals 10Q squared plus 1400, and the revenue is given by 4400 Q. So part A, how much does it cost to make 15 items? That's back from chapter 1. Part B, how much does each item cost when they are for sale? Also back from chapter 1. So then C, what is the profit function for this model? So setting up the profit function we've done before. And again, we do that by taking revenue minus cost. So then part D and E, this is where we're bringing in our chapter 4 stuff. So for part D, what is the quantity that maximizes profit? So what we need to do is we need to think about how we find maximums of a function, which is what we've been doing in chapter 4. And we are trying to maximize the function that we set up in part C, right? And then for part E, it says, what is the maximum profit? So we're trying to distinguish between the quantity that maximizes profit and what the maximum profit is. This is going to be a very important distinction. So we're going to try to sort of work through this. So I'm going to have you try this. Hopefully you remember some of the stuff from earlier for parts A, B, and C, but part D is really, D and E is what we've been doing in chapter 4. How do we find maximums is sort of the big picture question. So I'm going to give you about 4 minutes to try this out, see if you can get this set up, see if you can figure out how we do all of this, and then we will go through it together. Okay, take about 30 more seconds to finish up whatever part you're working on. Okay. So again, in this section, we are also going to be looking back to the things we've learned before. So we do have to sort of bridge that and pull in things that we've been talking about this semester. So for part A, how much does it cost to make 15 items? This is specifically the cost function, and we want to take 15 as our quantity and plug it into our cost function. So here we'll have C of 15. We're just going to plug in a 15 everywhere we see a Q. So we have 10 times 15 squared plus 1400. We'll plug that into our calculator and we'll get $3,650. So as a reminder, our units for cost, revenue, and profit are going to be in dollars. And so this is the cost to produce 15 items. Okay, so again, that just sort of goes back to plugging in and make sure we're plugging into the correct equation. Okay, for part B, it wants to know how much does each item cost when they are for sale. So the key piece here is for when they are in sale, right? And so that has to do with revenue. So revenue is when we sell our product. And as a reminder, revenue is price times quantity. So we want to go to the revenue function and we see this here. And so if revenue is price times quantity, then the number in our revenue function is the price that we are selling them for. Okay, so we are selling these for $4,400 each. And this one's a little tricky on interpretation because we see the word cost in the question, but we're not talking about the cost equation. We're talking about the cost to the buyer, which is the price. So we just have to be a little bit careful with how the question is worded and really think about what the intention of the question is so that we can answer it correctly. Okay, so for part C, we're looking at what is the profit function for this model. And so as a reminder, our profit function is going to be revenue minus cost. So we want to take our revenue function, which is 4,400Q, minus our cost function. Now, because our cost function has more than one term in it, we really want to use parentheses because that minus has to go to both terms. Okay, so we get 4,400Q minus 10Q squared plus 1,400. So it's our revenue function minus our cost function. And so part C is what helps us set up to answer parts D and E. So for part D, it says, what is the quantity that maximizes profit? So in order to maximize profit, we would have to set up the profit equation. So if we didn't have this question in part C, we would still have to do the step to set up the profit equation because we need the equation to be able to maximize it. So if we want to maximize something, whether it's profit or something else, we should be thinking critical points, right? We find maximums and minimums by finding critical points and then making sure that we are maximizing and not minimizing a function, right? So if we're looking for our critical points here, we're interested in when the first derivative equals 0. So if we take the first derivative of this function, the first derivative, the derivative of 4,400Q, 4,400 minus the derivative of 10Q squared is 20Q. The derivative of 1,400 is 0 because that's a constant with no variable attached. And we want to know when does that equal 0. So we would bring the 20Q over and then divide. And when you do that, you get Q equals 220. Okay, So that's your critical point. We want to make sure, however, that it's actually a maximum, because if you want to maximize profit and you accidentally minimize it, that would be problematic, right? And so we can use the second derivative test here pretty easily to make sure that it's a maximum. So the second derivative of our profit function is the derivative of 4,400 is 0. And the derivative of negative or minus 20q is just minus 20. And so remember, if your second derivative is negative, the second derivative test tells us that the original function is concave down, which does make this a maximum. So as long as your second derivative is negative at your point, then you know it's going to be a point that maximizes. Okay, and so even though we can't actually plug that value in, we talked about how you can still use the second derivative test, the sign of that, to classify your critical points. So Q equals 220 answers the question, what is the quantity that maximizes profit? The other associated question that comes up with this type of problem is part E, what is the maximum profit that can be achieved? So when we're looking for the maximum profit, we then need to take the quantity that maximizes our profit and plug it back into our profit function. So we're going to take 220 and we plug it in here. So we have 4,400 times 220 minus 10 times 220 squared plus 1,400. Be careful with your parentheses and where the minus is, okay? When we take all that, let's see, and we crunch that number, we are going to get $482,600. Okay, so again, units are in dollars. And what I will say is that when you're doing this type of problem where you're maximizing profit, typically you will only have question D or E. Okay, so it'll either say what is the quantity that maximizes profit or what is the maximum profit. So if you get the question that is just here's the cost function, here's the revenue function, what is the maximum profit that can be achieved, you need to set up the profit function. You then need to solve for the critical point, and then you need to plug that critical point back into the profit function to find the actual profit, right? So that's finding that Y value. We did that with global maxes and mins. So make sure you're reading the wording really carefully so you know if you're looking for Q quantity or the profit, right? Because if you're doing the profit, there's that one extra step. Okay, so that's, the I'd say the most common problem that you're going to see in this section is figuring out how to maximize profit, or sometimes revenue, which is the same idea, or cost, minimize cost, right? So when you see maximums or minimums, you're just thinking critical points and then applying what we know there. So now let's look at something that's a little more conceptual and analytical. We actually did a similar problem to part A back in chapter 2, so maybe you remember, maybe not. But let's see if Q represents the cost, R of Q represents the revenue, and pi of Q represents the profit of a product with quantity Q. Part A, when profit is maximized, what is the relationship between C prime of Q and R prime of Q? Part B, if C prime of 45 equals 57 and R prime of 45 equals 62, approximately how much additional profit is earned by the 46th item? Okay, so I want you to think about this, right? Think about conceptually, think about what you know and how you might be able to figure it out. I'd like you to take 2 minutes, see if you can work out parts A and B, or both, or neither, but think about what we know and how we might think about answering this particular problem. So take 2 minutes and then we'll go through it together. Okay, take about 30 more seconds. All right. So part A says when profit is maximized, what is the relationship between the derivative of cost and the derivative of revenue? So let's look at, again, the profit function for a moment. So profit is revenue minus cost, right? So if we were going to try to maximize this in a general way, right, we would need to find critical points by thinking about when the first derivative equals 0. So the first derivative, another color, of our function is going to be marginal revenue minus marginal cost. And we want to know, when does that equal 0, right? Well, if we were solving this, right, if we had numbers, we would be able to bring the cost over. So what we find is marginal revenue is going to equal marginal cost when profit is maximized. Our critical point is going to happen when those are equal. Now, we need to be a little bit careful because this is also where profit could be minimized depending on the function, right? So depending on how many critical points we have, it could be that there's a maximum and a minimum. So one is not exclusive of the other. So even though we know that we need this to be true for profit to be maximized, if there's more than one critical point, we could also have a minimum there. But that's sort of the thinking that we're hoping you can follow to really think about the relationship between these two quantities. So again, we started with just a general profit function. We thought about what it means to find a maximum, and then we're able to describe what that relationship might look like. Okay. For part B, we have if C prime of 45 equals 57 and R prime of 45 equals 62, approximately how much additional profit is earned by the 46th item? So the 46th item, we are talking about the marginal profit at 45. Now, why is it at 45? Because remember that the marginal anything, marginal profit, marginal revenue, marginal cost, is the additional profit to produce one more item, right? So when we talk about the marginal profit, we're talking about the additional profit going from 45 to 46, which is the same as the profit earned by the 46th item. So it's that one additional that we get. So that means that we're going to do marginal revenue at 45 minus marginal cost at 45. That's going to tell us the additional profit on the 46th item. So this idea of one additional item is really important. So that is 62 minus 57. So that means that the additional profit earned by the 46th item is $5. I also want to remind you that marginal profit or additional profit can be negative, right? So if marginal cost is greater than marginal revenue, then marginal profit can be negative. It just means we're making less and less profit over time. That happens as well sometimes. So the order of your equation is important. Profit is revenue minus cost. So when you're talking about marginal profit, it's marginal revenue minus marginal cost. So revenue always comes first. So keep that in mind when you're subtracting, that you always want revenue minus cost, whether it's in the original for something else or in marginal to talk about marginal profit. So the marginal profit here is $5. Okay, so the next problem has some parts. We're going to sort of walk through the parts here to figure out and learn how to set these up. This type of problem can be adapted into a lot of different applications in this genre, but this is sort of the overarching example so that you have this in your notes on how to set this up. Commonly, you won't have all the parts of this. It'll just be the question of like, how do you maximize this? So this is sort of breaking down the different pieces. So here we go. So a theater has 1,000 seats, and when they set their ticket price to $10 per ticket, the theater sells out. For each additional dollar charged, the number of seats purchased is reduced by 50. Find the linear equation that fits this data. Instead of using the variables x and y, we're going to be using q and p in our equation. So we are going to start by setting up what's called the demand equation. So what we need to do is we need to think about 2 points that we have from this information. The first point is that when it's $10, we sell 1,000 seats. Okay. So using this information, we need to find a second point, and you'll get that from the second line. And then from there, you're going to set up a linear equation. So, we set up linear equations with slopes, and we plug in the point to find our b. And so you want to find a linear equation. And then once you have your linear equation, you can either start off with q's and p's, or you can do y equals mx plus b. And then once you have your equation, turn it into q's and p's. But in the end, your final equation, right, should have the p's and q's in it instead of the x's and y's. So again, we want to take the information we have to get a second point, which you can get from the second line. Then we are finding the linear equation that goes through these 2 points. So that just goes back to sort of algebra. We're finding the slope, we're finding the intercept. So I'm going to give you 2 minutes to do this first part, to set up the linear equation, and then convert your x's and y's into your q and p. And then we will go through this part together, and then we'll move on to the other parts. So try that out. Okay, take about 30 more seconds. Okay, so I'm gonna do the work for this down here because we're going to be building onto it. So our first point was 10, 1,000. And our second point, you can actually set it up a couple different ways, right? So we have for each additional dollar charged, the number of seats is reduced by 50. So that means if I add 1 to the price, I subtract 50 from the number of seats. So that's the most common second point, but you could certainly, add $2 and subtract 100 seats if you like those numbers better. It'll all work out the same. But there's obviously many, many points on our linear equation. So here, right, we normally write our points x, y, right? But we're writing our points PQ, price and then quantity. I'm going to set up our linear equation using y equals mx plus b. And once I have the equation, I will then convert the variables. If you prefer to start with q and p, that's totally fine too. It's just a matter of preference. So we know that we're going to need the slope, right? So the slope in the line is going to be the change in y over the change in x. So we have 1,000 minus 950. So that's the change in y over the change in x. We have 10 minus 11. That gives us a slope of negative 50. Okay, so the slope of our line is negative 50. So we start off with a line that's y equals negative 50x plus b. We need to solve for b. So in order to solve for b, we want to plug in one of our points. It doesn't matter which one you choose, you will get the same answer. So I'm going to pick the first one just because the numbers look like they'll be a little bit nicer to work with. So when I plug in 10 for x, I plug in 1,000 for y. So I have 1,000 equals negative 50 times 10 plus b. So 10 times negative 50 is negative 500. I'm going to add that over. And I get b equals 1,500, which means that I now have y equals negative 50x plus 1,500, right? So we find the equation of the line in general, and now we want to convert it to match up with the right variables, which means that instead of an x, I'm going to have a p, and instead of y, I'm going to have q. So I have q equals negative 50p plus 1,500. So this is the linear equation, right? That's going to model this particular data. And this linear equation has a name. It's called the demand equation. Now, why is it called the demand equation? What it tells us is if we pick a price to charge, how many of those will be demanded by the general public? That's what we're trying to find out. So we know that if we charge $10, the demand will be 1,000 tickets. If we charge $11, the demand is 950 tickets, right? So we can figure out the demand for any price point with this equation. So when you have the type of information we have and you set up this type of linear equation, you get what's called the demand equation, okay? So now that we know how to find a demand equation, let's look at the next part of our problem here. So remember that revenue is price times quantity, okay? Where P is price and Q is quantity. We want to use our equation from part A, I should say part A, to set up a revenue equation by substituting the demand equation in for P. Okay, that's actually also a typo. Please hold. I don't know why there's two typos here. That's A and that's Q. Okay, so find the price and quantity that will maximize revenue. So what are we doing here? So for part B, we want to set up our revenue equation. So revenue is price times quantity. And now we're going to substitute in, instead of Q, we're going to substitute in what Q represents, right? So we're going to use parentheses and we're going to plug in our demand equation here. What that will do for us is it'll give us a revenue function that's entirely in terms of one variable, right? Price. And so from there, we can use that to find a maximum, right? So we can find critical points. And then once we have the critical point, right, we can make sure it's a maximum. And then from there, once we have the price that maximizes our revenue, we can then use that and go back and find the corresponding quantity by plugging it in here. So again, we're going to take our Q, we're going to plug it in here. We're going to plug in the function part. Then we're going to simplify. That's part B. Part C, we're looking for maximum. So that's when we're going to use our first derivative, find our critical points, and then we should be able to solve for P. Once we have P, we can use that to find Q. And we will find the price and quantity of tickets that we should sell that will maximize the revenue that we take in for this theater. Okay, so I'm going to give you about 3 minutes. Try that out. Again, the first part, you're just substituting in this equation for Q. And then from there, that's when the chapter 4 stuff of critical points starts. I do recommend that you distribute the P through before you do the derivative. I think that is helpful for the algebra. Okay, so try that out. Take about 3 minutes and then we'll go through it together. Okay, take about 30 more seconds. All right. So let's carefully walk through this one. So again, we're going to use our equation from part A, so our demand equation, to set up a revenue equation. And the revenue equation is really interesting because typically we have price, which is a constant, and Q, which is our variable. But when we have this type of problem where we have a demand equation, it makes price the variable because that's what we are trying to vary to maximize our revenue. So here, when we plug in our demand equation, we have negative 50p plus 1500. Okay, we want to distribute the p just to simplify. You don't have to, but if you don't, you end up having to do a product rule. And if you do distribute, then you don't need to do a product rule. So it just makes it a little bit easier. Okay, so we have negative 50p squared plus 1500p. So that's part B, right? We've set up this revenue function now that has just one variable in it, just price. So here, now we want to find critical points for part C. We're finding the price and quantity that are going to maximize our revenue. So here we start by finding the first derivative of our function. So the 2 comes down to multiply the negative 50. We get negative 100p plus the derivative of 1500p is 1500. And we want to know, when does that equal 0? Excuse me. So by solving this, this is going to give us the price that maximizes revenue. So we're going to add the 100p over. So 1500 equals 100p. We're going to divide both sides by 100. And we get p equals 15. Now remember, p is a price. So what that's telling us is that we should charge $15. How do we make sure it's a maximum? Well, again, we can look at the second derivative. It's probably the fastest way. So here, the second derivative is negative 100. If your second derivative is negative, the original function's concave down, and it's a maximum. So that's half of the question. Says find the price and quantity that maximizes revenue. So this is the price. We want to charge $15 to make the most amount of money. How do we find the corresponding quantity? Well, that goes back to the demand equation, right? The demand equation tells us how many tickets will be bought at a particular price. So to find our Q, we do negative 50 times 15 plus 1500, and we get 750. So P equals $15. The quantity that will be demanded is 750 tickets. And so then what is that maximum revenue, right? Like what is the amount of revenue that we would take in? That's another sort of spin-off of this. So the revenue is price times quantity. So $15 times 750 tickets gives us $11,250. And we can compare that to our sort of initial numbers here, right? If we sell tickets for $10, we sell 1,000 of them. Well, that's $10,000 if you multiply price times quantity. This is higher. So even though we're selling less tickets, we're selling them for more money. So we make a higher revenue. So here, the 3 sort of quintessential pieces of information are that we want to charge $15 to maximize revenue, that when we charge $15, we sell 750 tickets. And then from that, we can find the max revenue by multiplying those together, and we get $11,250. Now, I do want to point out that the way that this problem is commonly presented is that you are given this sort of start here. A theater has 1,000 seats, and they set their ticket price at $10. They sell out the whole thing, right? So this first setup of information, and then it usually just says like, find the quantity that maximizes revenue, or find the price that maximizes revenue, or find the maximum revenue, right? Which is the 3 pieces that we found down here. It doesn't usually have it broken up like this. So this is why you need to know how to find a demand equation, which is new to us in this realm, and then use that to then maximize revenue. Okay, so this demand equation is really important. And you can imagine that, you could change it from a theater to a baseball park or something else that you're selling. But the idea is that you have to start by finding the demand equation if you're maximizing revenue in any sort of meaningful way. Okay, so as I mentioned at the beginning of class, this particular section is intentionally shortened because you have to go back and review so much of the profit, revenue, and cost. So typically, what we would do for this particular section is I would stick around and answer any questions you still have related to this. So we're going to stop lecture here today, so you'll have some extra time in your life. But if you do have questions about profit, revenue, and cost from prior material that we've done, feel free to come up to the podium and ask questions. I'm happy to answer them. Otherwise, you can use this time to work on some homework, get a jump start on your next class or whatever it is that you need to do. But keep in mind that you want to be preparing for this section by also reviewing old material. Okay, so that's it for today. On Thursday, we will do our other two applications in biology and chemistry. If you don't stop by with questions, have a great day, and I will see you on Thursday.